What's up, you freaking geniuses? So, in this video, I'm going to teach you how to find prime factors of a composite number. Or in other words, how to perform prime factorization. Now, there's one thing we need to make sure you understand before jumping into this prime factorization topic, and that's knowing the difference between prime and composite numbers. So if you need to review that real quick, I'll link a video to that in the card above, but if you're good, we're just going to move on. Now, a key point that you need to understand about prime and composite numbers is that when you multiply prime numbers together, you get a composite number. Okay, so for example, if I took a prime number and I multiplied it with another prime number, any prime number, we would get a composite number as our answer. Okay, so let's take two prime numbers. Let's take 2 and 3. Okay, so if I did 2 times 3, 2 times 3 would give me 6, right? And 6 is a composite number. Okay, or I could do, a prime times another prime times another prime. And that would give us the same thing, a composite number. All right, so it doesn't matter how many prime numbers we have. The point is, when you multiply a bunch of them together, your answer will always be a composite number. Okay, so now, the point of this thing we call prime factorization is that I'm going to give you the composite number. And then through prime factorization, it's your job to figure out what all these prime numbers are. And thankfully, there's a couple easy methods of doing that. So the method I'm going to break down in this video is called the factor tree method. Okay, so let me give you an example of how we use that method. Okay, so I'm going to give you a number. Let's say 12. And then I'm going to ask you to find the prime factors of 12. So this number that I'm giving you is always going to be this composite number. Okay, so now it's our job to figure out what these prime numbers are supposed to be. So at this point, I'm going to ask myself, what two numbers can I multiply together to get 12? I'm going to say 2 and 6, okay? And I'm going to write those down underneath the 12. And I'm also going to draw little branches to each of those numbers. Now, at this point, I'm going to ask myself, do I have any prime numbers? Okay, well, let's check 2 first. Is 2 a prime number? It is. So, what do you do when you find a prime number? You're going to circle it, because we're going to keep track of it because it's part of our answer. Okay, so this means we just found one of our prime numbers. So let's try to find the others. Now, is 6 a prime number? No, right? 6 is a composite number. So that means I can simplify it or break it down. So I'm going to ask myself, what two numbers can I multiply together to get 6? Well, I can multiply 2 and 3, right? And then I'm going to draw my branches. Okay, now at this point, I'm going to ask myself again, do I have any prime numbers? And the answer is yes, right? We already know 2 is a prime number, so we'll circle that one. And 3 is also a prime number. Okay, so now there are no composite numbers left to break down, right? Because this is prime, and this is prime. So that means we're done. That also means we found all our prime numbers. So remember, we were given our composite number. And then the prime numbers that we found were 2, 2, and 3, okay? So if you multiply 2, 2, and 3 together, we should get 12. So let's check that. And we'll put our multiplication signs in here. So 2 times 2 is equal to 4, right? And then 4 times 3 is equal to 12. So that checks out. Okay, and I'm just going to rewrite this down here. So our prime factors were 2 times 2 times 3 is equal to 12. So this would be our answer, but we can simplify it just a little bit. So whenever you have a double number, right, 2 times 2, we can rewrite that with an exponent. So another way we can write 2 times 2 is 2 squared, right? So this 2 times 2, I'm going to write it as 2 squared instead. And then I'll bring down the rest of my answer. So times 3 is equal to 12. Okay, so this is your answer, and it is as simplified as possible. Okay, now one thing I want to point out is we were given 12, right? That's our composite number that we were given. Now, I broke it down into 2 times 6, right? But what if you didn't want to break it down into 2 times 6? What if you wanted to break it down into 3 times 4? Would that still work? Well, let's check it. So I just broke it down into 3 times 4, right? Do we have any prime numbers? Yes, we do, right? The number 3 is prime, so we're going to circle it. Okay, is the number 4 prime? No, the number 4 is composite, right? So we can keep breaking this one down. So I'm going to break this one down into 2 times 2, right? 2 times 2 is equal to 4. Okay, so I'm going to ask myself again, now do I have any prime numbers? Yes, I do. 2 is a prime number, right? So I'm going to circle both of these 2's. Okay, so now I don't have any composite numbers left. I broke everything down, so I'm done. Okay, so what are my prime factors here? I have a 3, I have a 2, and another 2. So let's multiply those out. So I have a 3 times a 2 times another 2. And that's supposed to equal our composite number that we started with, right? 12. Now, one thing I'm going to do real quick is just rewrite my prime numbers from least to greatest. Okay, so I'm going to just rewrite this as 2 times 2 times 3. So basically, I just moved the 3 to that side, okay? And again, we're saying this is equal to 12. Okay, so did we get the same answer? Well, here we just got 2 times 2 times 3 is equal to 12, right? And what do we get over here? 2 times 2 times 3 is equal to 12. So as you can see, we got the exact same answer, right? So when you're given a number to break down, it doesn't matter how you break it down, right? Because here I broke 12 down into 2 times 6, and then over here I broke it down into 3 times 4. But as long as you follow your steps correctly, you're going to end up with the exact same answer. Okay, and one last note I want to make about this problem is if you were given, again, the number 12, one way that you wouldn't want to break it down is by 1 and 12. Why would you not want to do that? Well, we started with the number 12, right? So the whole point is to break 12 down. But if you break it down into 1 and 12, you just gave yourself 12 again, right? So you didn't make any progress. You're back to where you started, right? We still have to break 12 down at this point. So at this point, you'd still have to break it down into something else, into either 2 and 6 or 3 and 4. So like we did in the other 2 examples. So whenever you're breaking a number down, never break it down into 1 and itself. Okay, so I think the method is pretty straightforward, but let's try one more example. Okay, now what if you were asked to find the prime factors of 36? How would we do this? Okay, so at this point you simply ask yourself, what are 2 numbers I can multiply together to get 36? And there's a few different ways we can do it, but I'm just gonna go with 3 times 12. Okay, so I have 2 factors right here. Whenever you break it down, you always ask yourself, do I have any prime numbers? Well, in this case we do, right? Because 3 is a prime number. What do you do when you find a prime number? You circle it. Okay, so this one's done. Now, is 12 a prime number? No, right? 12 is a composite number. We can still break this one down. So 12, I'll break down into, let's go with 3 times 4. Okay, so I just broke something down, so I'm going to ask myself, now do I have any prime numbers? Well, yes, I do, right? 3 is a prime number again, so we can circle that one. What about 4? Is 4 a prime number? No, 4 is a composite number because we can break this one down, right, into 2 times 2. Okay, so I broke something down. So again, I'm going to ask myself, do I have any prime numbers? Yes, I do, right? 2 is a prime number, so I'm going to circle both of these. Okay, so I don't have any composite numbers left. There's nothing left to break down, so I'm done. Okay, so now I'm going to write out my prime factors. What are my prime factors? Well, they're all these numbers that we circled, right? So 3, 3, 2, and 2. And what do we do with all these prime factors? We multiply them all together. And again, I'm going to write them from least to greatest. So I have a 2 and a 2. Okay, so 2 and a 2. And then I have a 3 and a 3, right? 3 and a 3. Now, when we multiply all this together, it's supposed to give us our original composite number, which was 36. Well, let's check it to make sure it does. What's 2 times 2? That's 4, right? And then we're going to multiply that by 3 times 3. What's 3 times 3? 9. 4 times 9 is equal to 36, right? So that checks out. So this answer right here, 2 times 2 times 3 times 3 is equal to 36, is our answer. But remember, whenever we have a double number like this, right, like 2 times 2, we can simplify that with an exponent. So 2 times 2, another way I can write that, again, is 2 squared, right? And then we can multiply that by this other double number, 3 times 3. 3 times 3 I can rewrite as 3 squared, okay? And again, this is all equal to 36. All right, so this is my answer, and it is as simplified as I can get it. All right, guys, so there's your introduction into prime factorization using the factor tree method. I hope it was helpful. If it was, definitely leave a thumbs up down below. It's always appreciated. And if you still got any questions, leave them in the comment section below, and I'll do my best to try and help you out. There's a whole pre-algebra playlist attached at the end of the video, so if there's any other topics you need to check out, definitely check those out, and I'll see you there.